everyone, welcome to our first lesson about surds. We're going to look at surds in terms of what they are, first of all, just to make sure we've reminded you about that. But then also we're going to look at how we simplify surds and how we expand expressions involving surds. Okay, that's what we're going to look at today. Then we'll look at a few more applications in our next lesson. All right. So first of all, I think we need to talk about what a surd actually is. Okay. A surd is an irrational number, okay, that is created through square rooting something, right? And before you can really understand that, we need to understand what rational numbers are. And rational numbers, okay, can be whole numbers, all right? So we've got an example in here in this circle. 1's a whole number, 3, 0, any whole number would be a whole number. Technically, the square root of 4 is a whole number, so we would consider that to be 2, so therefore it's a whole number as well. So we can see whole numbers written in different ways. I could have a fraction of 5 over 1, and that would still be a whole number because 5 divided by 1 is 5. Right, and then within that, we also have negative values, okay? So negative integers, okay, single digit or multiple digit numbers that don't have a decimal, okay? We can have positive integers as we see here, okay? Rational numbers include also anything with a terminating decimal, okay? So 4.5, that ends at 0.5, so that's fine, that's considered rational. Or anything that has a pattern to the decimal, okay, so like a recurring decimal. So this one here, 0.33333 forever, is considered to be rational because I could write that as a fraction, it would become 1/3. Negative 6 over 7, if I divided that, I would get a recurrence, and that would mean that it was rational as well. But when we look at irrational numbers like the square root of 17, negative the square root of 11, the square root of 2, all of those are never-ending decimals, just like pi. Goes on forever, doesn't seem to end, doesn't have a repeating pattern, and therefore we consider them to be irrational. Now, all of these numbers, rational numbers and irrational numbers, are real numbers, which must make you wonder what's not a real number. Well, we actually have something called imaginary numbers, but that's not something we really deal with until we are in A-level maths, okay? All right, so we're not going to worry about those today, as interesting as they might be. What we're going to worry about today are surds, which is or are a type of irrational number. Okay, so let's just get this ready so we can talk about that first question. Right, everyone. So, that's focused, good. Right, so we have a list of numbers here. They've given us negative 7. They've given us 4 over 9, root 6, okay, 0.2 with a dot above, and the square root of 25 over 49. And we need to figure out which ones are rational and irrational. Okay, well, this is an integer number, so that's definitely rational. Okay, this one here is a fraction with an integer numerator and denominator, so we consider that to be rational. Square root of 6, let's check on our calculator. Okay, right, and so there doesn't seem to be really any rational purpose to this. Okay, it doesn't repeat, it just carries on different numbers. So we would say that that's irrational, so that is a surd. Okay. This one here is recurring, okay, so we know that that's going to be rational, but let's show you why. If I said that x was equal to 0.2222 going on forever, I could then say that 10x was equal to 2.2222 going on forever. And I could create a little subtraction so that I could get rid of the decimal portion of this number. So if I did 10x, take away x, I would get 2.222 minus 0.222, and those bits would cancel. I hope you can see that. Okay, 10x minus x is 9x, and that would be equal to 2, which would mean that x would be equal to 2/9. So we know that that's rational. And that is exactly the same thing as that 0.2 recurring. Okay, so therefore it's rational. I've shown it in two different ways. Right. And finally, if I took the square root of 25, that would give me 5. And the square root of 49 would give me 7, which is an integer over another integer. And so this one is also rational. So really, the only one that isn't is this one here. Okay? All right, so that's a surd. It's irrational, and that's really what we needed to define before we move on. All right, so that brings us to me teaching you a little bit. Okay, the first thing we're going to look at is different surd rules. Okay, this is going to take a little while. I want you to take notes as we do this. Okay, I'm going to make this full screen so that you can see it a little bit more easily. All right, we're going to talk about how we actually work with surds. Okay. So let's take a look at something like the square root of 5 times the square root of 5. Okay, now I could turn that into the square root of 5 times 5, which I hope you recognize is the square root of 25, which would be equal to 5. Now, this was the square root of 5 times the square root of 5, and we got 5. All right, would that work for something else? Let's test it. Let's have the square root of 6 times the square root of 6. That would equal the square root of 6 times 6, which is the square root of 36, which is 6. Okay, so it looks to me like that works in this case as well. Does that work in general? Let's have the square root of n, which could be any number, times the square root of another n. That I can write as the square root of n times n, which gives me the square root of n squared. And you should know, I hope, that the opposite of squaring is to square root. Those cancel out, just like when we're solving. And that leaves me with n. So this works in general, okay? Lovely. So what does that do? It gives us a rule that we can use. Okay, so rule number 1, okay, is that if I take the square root of anything, multiply it by the square root of the same thing, that will give me that number itself. Okay, so the square root of a number times the square root of the same number will give me the number itself. Okay, and that's the first rule I want you guys to know. Very important. You might want to highlight it in your notes. Okay? Right, lovely. Now, this rule brings us to another rule, okay? So this multiplying, where we've got two surds that we're multiplying together, and then we bring that product underneath the root sign, okay? We can do this regardless of the numbers. So for example, if I had the square root of 2 times the square root of 5, then I could write that as the square root of 2 times 5, all underneath the root sign, which would give us the square root of 10. Okay? So that brings us to my second rule. All right, and rule number 2 is that if I have the square root of a number and I multiply it by the square root of another number, then I will get the square root of the product of those numbers. Okay, so that's our second rule. Again, super important, so might want to highlight it. So I know you know that multiplication and division are opposites, so we can relate this now to division slightly differently. Okay, so let's take a look at that. Remember, if I go too quickly, it doesn't matter because you can rewind the video. You can always go back and make sure these are in your notes beautifully. Okay, but I'm going to move on to rule 3. Right, so if we think about division, yes, I could have the square root of 50, and I could divide that by the square root of 5. Okay, I can actually write that as the square root of 50 divided by 5. So just like we did with the multiplication, everything goes under the same root sign when we're dividing. And that would give us 50 divided by 5 is the square root of 10. Okay? I could have written this differently. Okay, usually in maths we tend to use fractions for division. So actually, more likely you're going to see it like this, okay? And you're going to change it to the square root of 50 over 5, like a fraction. And then you can say that that's the square root of 10. It's the same question. It's just we're more likely to see it as a fraction than with a divide sign, okay? And that brings us to our, what are we on? Our third rule, okay? So rule number 3. And this is relating to the division aspect. So if I take the square root of a number and I divide it by the square root of another number, then I can divide them and put them under the same square root sign. So m divided by n, all under the same square root sign. We're allowed to do that. We could go the other way as well, okay? So don't forget, if I can go this way, then I can change that back to here. Same with rule number 2, okay? When we did that one, I could go from here and split it up into here. In fact, that's going to become really important when we simplify, okay? But back to rule number 3. If I have 1/3 divided by another third, okay, then I can create that fraction there by dividing underneath the same root sign. All right, so let's highlight that for us in our notes. Okay, you can make a little bubble around it, whatever makes you happy, okay? But that is our third very important rule. Right, so almost there. How do I then add and subtract surds? Okay, well, the first thing I'm going to say to you is that your base surd has to be the same. So what do I mean by that? Root 3 plus root 2. I can't do anything there. That just equals root 3 plus root 2. Done. There's nothing else I can do. I can't simplify that. It's just like saying x plus y is equal to x plus y. I can't magically bring them together. They're separate things. They're apples and oranges, okay? Right, which brings us to how do we work with surds? Okay, I can do something like this. Let's say I have 5 root 3 plus 2 root 3. Well, that means I have 5 of the root 3's plus another 2 root 3's, which means I'm going to have 7 of them, which we write as 7 root 3. Oops. Don't know why I did that. Sorry. Okay, 7 root 3. Same with subtraction. So I could have something like 8 root 2 minus 3 root 2. And there's 8 root 2's minus 3 root 2's, which means I'm going to get 5 root 2. Okay, so I can, just like in algebra, add and subtract surds. I just need to make sure that the surds themselves are the same as each other. Otherwise, it won't work. Okay, all right, so we've gone through quite a bit there. Yes, what might be an idea as a little rule, number 4, is to write this down in general. Okay, so let's say I had m of root a plus n of root a. Well, that would become m plus n of root a. Okay, that rule is what I just explained there. Okay, and same with minus. If we want to show that as well, we can show that as a second line. M root a minus n root a would become m minus n root a. Okay, so that is our last major rule at the moment. So let's have you highlight that as well in your notes, please. Okay, so there's our adding version, and here's our subtracting version. All right, so hopefully that makes sense. Okay, that allows us to move on to your first question. All right, so let's just freeze that so you've got it there. Okay, and let's have you try, make that full screen, okay? Can you pause the video now, and you are going to try those 2 questions for me, okay? And then we'll talk about them. Okay, well done. Let's take a look. Right, so in these questions, so if we look at question 1, this is very similar to what I just taught you, okay? So in 1a, we have root 5 times root 5. Okay, we should know from the first rule we went through that that is the same as saying the square root of 5 times 5, which is the square root of 25, which is 5. If you went straight to the answer of 5, that's perfectly fine. This would only ever be worth 1 mark, okay? So I'm happy for you to go straight to there once you recognize this, okay? But for now, if you didn't recognize that, then working through it this way is perfectly fine as well. Okay, but the answer is 5. Part B, we have 7 root 3 minus 4 root 3. Okay, my surd is the same, so it's just like in algebra. 7 root 3 minus 4 root 3 will give me 3 root 3. Done. Okay, and part C, we had 3 root 2 plus 5 root 2. Okay, 3 root 2 plus 5 root 2 will be 8 root 2. Because the surds are the same, so we can add them together. All right, lovely. Hopefully you guys got that. Question 2, part A, is forcing us to go the other way, so we're splitting something up. So 6 is the same as 2 times 3, so I can say that root 6 would be the square root of 2 times the square root of 3. Okay? Part B gives us on the right root 5 times root 6. Well, 5 times 6 is 30, so I could change that to the square root of 30. Okay? And finally, part C, we have on the right the square root of 5 over the square root of 7, but that would have started as the fraction underneath the surd, 5 over 7. Okay, so you have to work both ways here, depending on the question, and hopefully we were okay with that. Right, lovely, really proud of you. Right, so now we're going to talk about simplifying surds in a little bit more detail, just to make it a little bit easier for you when you do the next set of questions. Okay, so, and this works with this rule here, that the square root of m times the square root of n is equal to the square root of m times n. And what this is going to allow me to do is when I move this way with this rule, okay, I can start to pull out numbers that have a perfect square root. And that's part of simplifying a surd. So let me give you a little bit of an example. Let's say I had the square root of 75. Well, that I can change to the square root of 25 times 3. Now 25 I want to take out because 25 has a square root. So I can now write this as the square root of 25 times the square root of 3. We don't need to bother with a times sign. It gets in the way. Okay, so at this stage I wouldn't use one. And the square root of 25 is 5. So actually this equals 5 root 3. And that is considered to be simplified. Okay, let's take a look at a different one. Let's have the square root of 48. Okay, well, you're always trying to take out the biggest square number. Yes, you're thinking about your factor pairs. So I would have 1 and 48, 2 and 24. Neither of those are square numbers yet. But when I do 3 and 16, look, 16 is a square number. So actually I want to use this pair. So I can say that this is the square root of 16 times 3. Notice in both of these I've chosen to write my perfect square number first. And that's because when I simplify, I want that in front. Okay, so 16 times 3 is better to write than 3 times 16. That's going to give us root 16 times root 3, which is 4 root 3. Okay, and that's how we do that one. Right, so I'm hoping that makes sense. I'm going to do one more just to make sure you're fine. So let's say we have the square root of 200. Okay, that we could write as the square root of 100 being our square number times 2. And that will give us the square root of 100 times the square root of 2, which will give us 10 root 2. Okay, right, so hopefully that's fine. And we're going to get you to try the next question. Okay, so press pause, have a go, and then we'll talk about the answers. Okay, well done, guys. Let's take a look. Right, rock stars, here we go. Okay, so 3A, we have the square root of 50, and they're wanting us to make it the square root of something times 2. So times the square root of 2. Well, that would be 25. 2 times 25. Okay. And that is going to give us 5 root 2. And so therefore our answer is k is equal to 5. Part B, we have root 18. Okay, think about it. That's going to be 9 times 2. They've given us the 2 as a hint. Okay, and that's going to become 3 root 2, meaning that k is equal to 3. And finally, part C, we have the square root of 48, okay, is equal to, well, I've done this one with you. All right, so root 16 times root 3, which is equal to 4 root 3, okay, which would mean that k is 4. Lovely. So I think you guys are getting that, which is excellent. We're going to move on to the next concept, okay, which is rationalizing a denominator. Right, now, let's make that full screen again for you. Okay, so when I rationalize a denominator, what that means is I don't want to have a surd in my denominator. So, for example, if I have 1 over the square root of 3, I don't actually want that. I do not want a surd in the denominator, okay? It's difficult with maths to have a surd in the denominator. We can't really work with it well, so we always have to rationalize this. And to rationalize it, I need to make sure that my denominator is a whole number, okay? Right, so how do I do this? Well, I'm going to use this rule here. So hopefully you remember that root a times another root a would give us a. Okay, so that was one of our rules earlier. I think it was the first one we did. Okay, and I'm going to use that to help me. If I multiply the denominator by root 3, that's going to become a 3, which is what I want. But because it's a fraction, I have to remember to do the same to the top. Okay, so if I do that, that's going to give me root 3 over 3, which is now rationalized, and that's what the question would ask me to do. Okay, so just a reminder, this is how we rationalize a denominator. Okay, so let's try another one. Let's say I had 2 over the square root of 5. Okay, well, in this case, I'm going to want to multiply by root 5 to make that a 5, and I have to do the same to the top. 2 times root 5 is 2 root 5, and that is all over root 5 times root 5, which is 5. Okay, and now that is rationalized. Right, we'll take a look at one more example. Let's say I had 3 over 2 root 3. Right. Now, I'm not going to multiply by 2 root 3. That's a bit silly. It's only the root 3 I need to get rid of and rationalize. So I'm going to just multiply by that surd, root 3 and root 3. Okay? So on the top, that is going to give me 3 times root 3 over 2 times root 3 times root 3. Well, root 3 times root 3 is 3. So that's going to be 6. Okay? But now I can cancel. Okay? So we're going to have that becoming a 1 and that becoming a 2. So my final answer is root 3 over 2. And I'm done. All right, so it's your turn now. You are now going to work on this question here. Okay, let me make that full screen for you. Off you go. And press pause and then press play when you're ready to go through the answers. Okay, guys, super work. Let's take a look. Okay, so in 4a, we are looking at 1 over root 10. Okay, root 10 is what we need to multiply by to rationalize the denominator. Same with the numerator. And so that will give me root 10 over 10. Okay, part B, you had 3 over the square root of 15. Okay, so for this one, we're going to multiply by root 15. And same with the top. Okay, and that is going to give me 3 root 15 over 15. Please remember to cancel down at this stage, 1 and 5. So my final answer is root 15 over 5. Okay, and part C, we have 8 over root 32. Okay, so we are now going to multiply by root 32. Okay, and that is going to give me 8 root 32 over 32. That cancels down, 1 and 4. So we get root 32 over 4. Now, you have to ask yourself, can I simplify this any further? And actually we can, okay? I could have simplified here first. That's not really the skill we were working on, so I chose to multiply by root 32 first, okay? But I could have simplified here. I'll show you that in a moment. Right, so let's take a look at root 32. Well, that could be 1 times 32. It could be 2 times 16. Oh, that's good, because that's a square number. So we're now going to change this to root 16 times root 2 over 4, which we know is 4 root 2 over 4, because the square root of 16 is 4. And that gives us, when we cancel that, root 2. So our final answer there is root 2. That simplifies, so that complicated thing goes straight down to this, which is another cool thing about the surds. But let's go back to how I could have done this in the first place. So what might have been smart is for me to simplify here. I could have turned this into 8 over root 16 root 2. Okay, that would have given me 8 over 4 root 2. That would have become a 1, and that would have become a 2. That would give me 2 over root 2. I would now multiply by the root 2. Okay, and that would give me 2 root 2 over 2, which would cancel to the same root 2. Okay, so quite important, and that is how we do that. Right, lovely. So I've got one more thing to teach you before we try the questions. Okay. All right, and that is simplifying and collecting surds. So let's make that full screen again. All right, so this is a situation where we're now combining the concepts of adding and subtracting surds, but first we simplify them. So what I mean by that is, let's say I have the square root of 50, and I would like to add that to the square root of 200. Okay, so I'm going to have to simplify the surds separately first. This one I know can be 25 times 2, and this one here can be root 100 times root 2, and you'll notice that those root 2's are going to have to match. Okay, so however we simplify these, I need to make sure that my surds will match. Now I can simplify further. That becomes 5 root 2 plus 10 root 2, which means my overall answer is 15 root 2. Okay, so by simplifying those separately, I ended up getting to here. Right, lovely. Let's take a look at one more. So let's say I had the square root of 75 minus the square root of 48. Okay, so let's simplify. This one can become root 25 root 3. And this one here can become root 16 root 3. Again, notice that those are the same. Okay, we can change this to 5 root 3 minus square root of 16 is 4 root 3. And 5 minus 4 is 1. So I'm left with just root 3. Okay, and that is how I would simplify and then calculate or further simplify and collect the like terms. In this case, those like terms are actually the surds. Okay. All right, so I'm hoping that makes sense. Let's take a look at these questions here. Make that full screen for you. Okay, so can you pause and try those, and then we'll press play to go through it. Okay, guys, well done. Let's take a look at how we do these questions together. Let me just get the visualizer up and running. There we go. Okay, so in this first bit, so we look at 5a, part I, they said to simplify the square root of 45. So again, we are looking for a product, okay, or two factors here, a factor pair, that will have one of the factors having a perfect square root. So in this case, we can split this into 9 times 5, which will be root 9 root 5, which will then give us our 3 root 5. So now I've simplified that one. Let's look at part 2, where we have the square root of 20. Okay, we can turn that into 4 times 5, so that's root 4 times 5. And that will give us root 4 root 5, which will give us 2 root 5. Now you can see why this is part 1 of the question, because you can see that these are going to be used in part B, and these are already simplified. So that's what we're going to do. So when we look at 3 root 45 plus 7 root 20. We've already given ourselves the hint here, so we're going to go straight to this step. Okay, we're not going to bother writing that one down now. All right, so that's going to equal 3 times root 9 root 5 plus 7 times root 4 root 5. Okay, and that's how you would show it in an exam. That is equal to 3. Now you can use a time sign or a bracket. It's up to you. But that is 3 times 3 root 5 plus 7 times 2 root 5. So I've chosen a bracket, but you could have used a time sign. And 3 times 3 is 9. So that's 9 root 5 plus 7 times 2, which is 14 root 5, which gives us a final answer. 9 plus 14 is 23 root 5. Okay, and that's our final answer for question 5. All right, let's move on to question 6. So for 6a, we have 2 root 75 minus 3 root 27. Okay, let's take a look. So root 75 we can split into 25 times 3 and 27 into 9 times 3. So let's do that next. So 2 root 25 root 3. So once again, I don't now need that middle step where I have 25 times 3 underneath the square root. I can go straight to this. Minus 3 root 9 root 3. Okay, that is going to be 2 times the 5 root 3 minus 3 times 3 root 3. And that's because, as we know, the square root of 9 is 3, and the square root of 25 is 5. Okay, 2 times 5 is 10 root 3. 3 times 3 is 9 root 3. So we get 10 minus 9, which is just 1. Root 3, we don't need to write the 1. And we're finished, part A. Okay, so in part B, we had the square root of 200 plus 3 root 32. Okay, so let's take a look at the 200. We've done this one before, 100 times 2. So we can write this as root 100, root 2, plus 3, and root 32. Well, okay, I've got 8 times 4, but I also have 16 times 2, so I'm going to choose that because that's a bigger square number. So root 16, root 2. All right, that gives us 10 root 2 plus 3 times 4 root 2, because root 16 becomes the 4. And that gives us 10 root 2 plus 12. 3 times 4 is 12 root 2. And that will give us finally 22 root 2 when I add the 10 and the 12. Okay. And finally, part C, we have 5 root 18 minus the square root of 128, and then plus 4 root 8. Okay, so let's start with this first one. That can be equal to 5 root 9 root 2. If I divide that by 2, because there's my hint, I'm going to want a root 2. I get 64, so that will work. Minus root 64 root 2. Okay, and then plus 4 times root 4 root 2. Now we can simplify by doing the square roots. So this is going to be 5 times 3 root 2 minus 8 root 2, and then plus 4 times 2 root 2. Okay, that's going to be 15 root 2 minus 8 root 2 plus 4 times 2, 8 root 2. That's nice. Those cancel out, which leaves us with a final answer of 15 root 2. Done. Okay, right, so I'm going to make this one full screen for you, and you're going to try it. Okay, and then we'll go through the answer. So please press pause and try the question. Okay, well done. Let's take a look. Okay, right, so in question 7, it says to us, factorize these expressions. The first one has been started for you. Fine. Okay, so we've got A being root 12 plus 2, and they've given us 2 root something plus 2. Okay, so let's do that first step. So think about this. The root 12 could become root 4, root 3. And root 4 is 2, so let's make that 2 root 3 plus the 2. And if I factorize, I can take out the 2, leaving me with root 3 plus 1. Okay, so a little bit of extension. Can you now factorize something with a surd? Okay, and we can. 2 times root 3 would have given me 2 root 3, and 2 times 1 would have given me 2. All right, so part B, we have 9 plus square root of 54. So let's see about simplifying that. So it's going to equal 9 plus, well, 9 times 6. Okay, so let's do root 9, root 6, which is going to be 9 plus 3 root 6. It did say to factorize, and my common factor here is the 3. So that's going to be 3 times 3, and then 3 times the root 6. So there we go, we factorize now. And part C, 18 minus the square root of 45 is equal to 18 minus root 9 root 5, which is equal to 18 minus 3 root 5. 3 goes into both, so we can say that that is 3 times 6 minus root 5 when we factorize. And part D, we have root 75 minus root 50. Okay, so let's have a think. We might not be able to fully factor. We'll see what we get. Oh yeah, we can factorize because this is going to be 25 times 3, and that one's going to be 25 times 2. So we're going to get root 25 times root 3 minus root 25 times root 2, which is going to give us 5 root 3 minus 5 root 2. And now I can divide out the 5, which is where the factorizing comes in, and we're left with root 3 minus the root 2 in the bracket. All right, lovely. So well done. Right, you have one more question to do. It's an exam question, so I want you to take a look at it and have a go. Okay, I've given you... Oh, no, we're not quite at the exam question yet. Sorry. One more question, then we'll do the exam question. So have a go at question 8. Okay. You're going to expand it just like you expand over brackets. So pause the video now and have a go. Okay, let's take a look, see if we understood that. Right, so here we go. So in question 8a, they're asking me to expand and then simplify this one here. Okay, so when we expand brackets, you should remember that you are multiplying by both parts inside the bracket. So that's going to be 4 root 5. I'm going to write the number first because that's what we do with surds. So 4 root 5 plus root 5 root 5. Well, we should know that root 5 times root 5 is 5. So that's 4 root 5 plus 5. Done. Okay, part B, we have double brackets now. So root 7 plus 1 and 4 plus root 7. Right, so that's going to give us root 7 times 4, which is 4 root 7. And then plus root 7 times root 7. And then plus 1 times 4, which is 4. And then plus 1 times root 7, which is root 7. Okay, let's simplify this. We get 4 root 7 plus a root 7 is 5 root 7. And then this becomes 7 plus the 4. And then we end up with 5 root 7. And we bring the numbers together, plus 11. Done. Okay, part C. We have 6 minus root 2. And then 4 plus root 2 in our brackets. So 6 times 4 is 24. 6 times root 2 is plus 6 root 2. 4 times negative root 2 is minus 4 root 2. And negative root 2 times root 2 is minus root 2 root 2. Okay, so that gives us 24. Now 6 root 2 minus 4 root 2 is plus 2 root 2. This becomes 2, so minus 2. And finally, 24 minus 2 is 22, minus the 2 root 2. Okay? Part D, we have 2 minus root 2 squared. So when we solve it, we need to write it out twice because we're squaring that bracket. 2 times 2 is 4. 2 times minus root 2 is minus 2 root 2. Negative root 2 times 2 is also minus 2 root 2. And negative root 2 times negative root 2 is plus root 2 root 2. Negative times a negative gives us a plus, okay? So we've got 4. Now a minus 2 root 2 minus another 2 root 2 is minus 4 root 2. And then this becomes plus 2, giving us a final answer of 6 when I bring those together, minus 4 root 2. Okay. Moving on to part E. We have 4 minus root 10 squared. So again, we're going to write that out twice in order to expand. 4 times 4 is 16. 4 times negative root 10 is minus 4 root 10. Negative root 10 times 4 is minus another 4 root 10. And negative root 10 times negative root 10 is plus root 10 root 10. That's going to give us 16. Minus 4 root 10 minus another 4 root 10 is minus 8 root 10. And then plus the 10. And 16 plus 10 is 26. So we get 26 minus 8 root 10. Okay, well done. One more. Okay, and part F, we have 7 plus root 3 times another 7 plus root 3. So we write it out twice. 7 times 7, 49. 7 times root 3 plus 7 root 3. Root 3 times 7 plus 7 root 3. Root 3 times root 3 plus root 3 root 3. Okay, 49. 7 plus 7 is 14 root 3. Okay, and that becomes plus 3, giving us a final answer of 52 plus 14 root 3. Lovely. Okay, really well done. We technically could go further with those if they asked us to and factorize some of them, but they haven't. They just said to simplify. And in our answer, they've been in this format. Okay? All right, so well done on that. I would like you to now try the exam question, okay, and see how we do. So let's make that full screen, press pause, have a go, and then we'll make sure we got it correct. Okay, well done. Let's see how we did. Okay, only 2 marks, all right. We start off with the question saying that we have 5 minus root 5 squared. Okay, so when we expand this, remember that because it's squared, we write it out twice, making that expansion a lot easier for ourselves. And then we expand the double bracket. So 5 times 5 is 25. 5 times negative root 5 is minus 5 root 5. Negative root 5 times 5 is minus 5 root 5. Okay, and negative root 5 times negative root 5 is plus root 5 root 5. At this stage, we have 25. Those are both negative, so we get minus 10 root 5. And this becomes a 5, which gives us a final answer of 30 for the 25 plus 5, minus 10 root 5. Now, it says where a, b, and c are integers, we are in the correct format. Just to be safe, we can now write that a is equal to the 30, b is equal to the negative 10, and c is equal to the 5. Okay, and that's that exam question finished. All right, they didn't say you had to state a, b, and c, so this is an extra step, but it's just making it very clear that we have put it in the correct format where that is a, that is b, and that is c. All right, I think you've done really, really well today. Okay, we will move on to the second part of Surds next lesson, and well done.